Well, thanks again for joining us at the fourth Data-Centric AI webinar, the October edition, so to speak. Those of you who aren't joining us for the first time know that this is for us an opportunity to share some of the work and thinking we're doing in interdisciplinary research, policy and advocacy on topics broadly related to AI, in particular the role of data, resources, stewardship, governance, communities, in creating a healthy AI ecosystem, whether that means technology or processes or regulation. In this series, as I said, this is the fourth webinar, and we had 3 excellent speakers so far on a range of topics. There's this massive QR code on the slide for you if you're interested in watching or re-watching the recording. So we had 3 topics ranging from how you create data sets that are diverse and less biased for safety testing. Then we moved to data scraping. And then in September, we talked about workers' rights when AI is used in the workplace. Today's speaker is someone very special to me. He was also an expert in data in AI in many ways that he will be unpacking today. So our guest today is Denny Vrandečić, who is the head of special projects at the Wikimedia Foundation. Those of you who don't know what the Wikimedia Foundation is, it is the foundation that stewards Wikipedia and many other projects. So Denny has been working in that community for many, many years. I think ever since I've met him in 2005. Denny and I did our PhDs more or less at the same time in an area related to symbolic AI. So that's a part of AI where we are writing data in formal logic, in mathematical notation. So that's a lot of fun, but also means that with that sort of an artifact, you have less concerns about proving that a particular AI capability is safe or not, because you have a mathematical proof or a similar type of formal verification to have some certainty that your AI will behave in the way that the designer intended it. Well, Denny went on to contribute to a number of hugely influential projects and data sets in the AI community, including Semantic Media Wiki, Wikidata, and now Abstract Wikipedia and Wikifunctions. And I'm very, very much looking forward to your presentation and your unique views. Over to you.
Thank you so much for the introduction, Elena. And I'm really happy to be here and present at the webinar. Let's see if I can present easily.
Presentation is on the screen.
But including the...
It includes the tab, but also now we have just the slides.
Perfect. That's what I wanted. Thank you. Thank you again for the introduction, Elena, and thank you for the opportunity to present here at the webinar. I'm really happy. As Elena said, I'm working for the Wikimedia Foundation. This is the NGO supporting the Wikimedia movement and the organization behind Wikipedia, which you probably heard about. Wikipedia is the free encyclopedia that everyone can edit. Our vision is a world where everyone can share in the sum of all knowledge. How are we doing with regards to that vision? Well, Wikipedia today is available in more than 300 language editions and provides more than 60 million articles in those languages. But it is wrong to assume that there is only one Wikipedia. In reality, there are those 300 and more different Wikipedias. Each of the language editions are independent. And if you put, for example, some knowledge into one of the Wikipedias, it won't be available on the other ones. It won't propagate automatically through that. This is mostly manual process to push the information from one to the other. This also means that the knowledge is very unevenly distributed in Wikipedia. We have some wikis, like the English Wikipedia, that have like 10% of all those articles. And other wikis, like the Turkmen Wikipedia, an official language of Turkmenistan, spoken by more than 4 million speakers, have fewer than 7,000 articles. That's a factor of about 1,000 of difference. These days, everyone is telling us that knowledge should be mediated through large language models, such as ChatGPT. And maybe that will be happening in the future, who knows? But I don't think that the current architectures support these use cases yet. And I'll take a look at a few examples that show the weaknesses of those systems. And just to point it out, the systems are amazing in what they can do, but I also want to point out what they're not so good at. So, this week, in preparation for this talk, I asked ChatGPT where I was born, and it answered with Stuttgart, Germany. And that's
just a second, Denny. Sorry about this. So, it seems that at least someone said that they cannot see any slides, just face.
Oh.
I can see slides, so I don't know if that. I'm just looking for some confirmation from my colleagues if they can see the slides.
Yeah, we can see slides too.
Is there anyone in the audience who can't see the slides?
Oh, so maybe for the person switch their own mode of what they're watching.
All right.
Okay. Shall I continue?
Yes, please.
Okay. So I said I was asking ChatGPT where was Denny Vrandečić, where was I born? And we get this answer, Stuttgart, Germany. Now, the interesting thing is, if I ask the same question in Croatian, gdje je rođen Denny Vrandečić, in my native language, I actually get a different answer. It tells me that I was born in Split in Croatia. So think about what that means for the representation of the knowledge in ChatGPT. Depending on the language I ask, I get different answers. And it doesn't even matter if this is one correct or the other one. Just this fact alone, that I'm getting different answers, even though I'm asking exactly the same question, is very interesting for knowledge representation. And if you don't believe that gdje je rođen Denny Vrandečić means the same thing in English, here's the proof. I asked ChatGPT to translate it for you. So you see, it's really the same meaning. And you trust ChatGPT, right? So I asked, in order to illustrate the answer, I asked Gemini, just to go for another one, to give me a map highlighting Split and Stuttgart. And it did so, I guess. Well, here's the result that we got from that one. But is it maybe the case that my place of birth is just very contentious and, on the line, like similar to, for example, the map of China and India where the actual border is, or the nationality of Nikola Tesla, or where hummus is from? All these questions that have genuinely different answers depending on which language you may ask. Well, I don't think so. So there is not a single source on the web that I could find that claimed that, in no matter which language I was searching, that claimed that I was born in Split, Croatia. There's just nothing that the system would have found anywhere on the web. So what is going on here? Where does this come from? The way that ChatGPT works is you have this large language model, right? And you ask as a user, you ask a question to the model, and then based on the question, it tries to create an answer in the form of very advanced autocomplete more or less. So it gives you the answer, and based just on the knowledge that it has in that system. And this obviously, it has only the knowledge accessible, which is already in the system, which has been trained on and which has been looked for. So it can only use that one. And this has led to a lot of errors. A lot of people have made fun of this and so on. So the architecture of the system was widely improved with something called retrieval augmented generation, where once you ask a question, ChatGPT doesn't only rely on what it has in its model, in the internal weights and so on, but it goes actually to the web itself. It makes a search on the web, it reads the results, and then it answers your questions based on this knowledge that it just acquired. Should work a lot better, obviously, but still fail, and it does work in a lot better in many cases, but it still fails frequently. Just a few weeks ago, I asked the question, what are the 10 largest cities with a female mayor? And here's one of the other features of ChatGPT and those other LLMs. It looks all very, very convincing, right? I mean, you look at this question, and say, oh yeah, those answers looks good. Those are big cities. It looks fine. And then you might be noticing, oh wait, those are all cities in the US only. I didn't ask for the largest cities in the US yet. Just suddenly decided it will give me that answer about the US. Well, at least that's not a bias. It will ever be a problem, right? So I asked again to be more, to be really explicit about, I want the 10 largest cities with a female mayor worldwide. So he gave me those answers. Again, looks very promising, looks very, right. I might wonder, like, why does it say for Mexico City until recently? Why does it list the former mayors below? But let's even skip that problem. We just saw in that page before that Los Angeles was listed with 4 million people. In this list, there is no Los Angeles, even though we know that Los Angeles is bigger than, for example, Berlin or Warsaw. So what's going on here? Why is Los Angeles missing? In order to figure that out, I was asking, okay, well, give me also the populations for those cities. Can you list the populations? And it gives me again the list, and now it gives me the populations. And I can see a number of things. First, it's not sorted by population in any way. Well, I didn't ask for it to sort, so why not? But what is even more interesting, can you list the populations led actually to a complete, but also we see, for example, that Los Angeles is indeed missing because we have here Stockholm and it with less than 1 million people, and Los Angeles is bigger. But even more interesting, just asking for the population actually gave me a completely different answer. These are now the two lists side by side. And we see that, for example, here we have Mexico City on the one side, and the other side we have a two in Paris. They have changed their order. But then we have Sao Paulo over there, and we have Bangkok on the other side, and so on. So just asking for the population changed the actual cities that were here listed, and Los Angeles is still not on the list. This kind of question is called a global query, usually, which means that it's not based on the content of a single document, but rather based on knowledge which has been accessed from many different documents. So, and LLMs are known to be better with local queries than with global queries because you can just rely on a single document, get an either remembered in the model, or gotten with the RAG system by reading for that. And here's a really disappointing thing. So we can see that both of these have actually searched the web, that it has asked for a few sites and used its query. And there are websites on the web which literally list the answer. So it's the first web result, at least if you search on Google. So we should have expected actually the system to read this article and give us a good answer, but it doesn't. Let's switch the topic completely for another problems that LLMs have. Computations. So computers are supposed to be pretty good at computation, right? But a few weeks ago, a paper came out checking out on ChatGPT 01, which is like the successor of ChatGPT 4. This is the newest model, touted to do all things like reasoning and so on. So what it was tested on is on multiplying numbers. So it was taking longer numbers. You can see numbers up to 20 digits on both sides, and how accurate the result is. Creating this chart was probably very, very expensive for the research that was doing. This was the University of Waterloo. And they've shown that basically if you have bigger numbers, the results are just not particularly convincing, just fail completely. And again, this is a system that was widely claimed to do reasoning very well and so on, and we still have those kind of errors. And this summer, for example, we had this whole news cycle about how these AIs can't figure out things like how many R's are there in strawberry and so on. So that they give the wrong answers there. What's going on here? Why can't these very expensive models not count letters, consistently answer my place of birth across languages, or multiply numbers? And I think the solution for how to fix this is to actually really separate language capabilities and the knowledge that those systems are using to answer the questions. To use the LLMs to understand the questions and to formulate the answer so that the human can really benefit from it, and the kinds of knowledge needed to answer those different questions. And here's an intuition why I believe that this is really true. So about 2.5 years ago by now, a model came out called Stable Diffusion, and it was able to generate images. It wasn't a text model, it was just for generating images. And here's, for example, the results for a query for asking for several famous people to explain knowledge graphs. And the thing is, you can actually probably recognize a number of those people here in the picture. Now, this model had 890 million parameters. And for me, that sounds like a whole lot. It's a big number. But in fact, compared to those modern LLMs, that's basically nothing. The estimates for ChatGPT-4, OpenAI doesn't actually release the numbers probably, but the estimates up around 1.7 trillion parameters, not billion, but trillion. So it's about 2,000 times larger than Stable Diffusion was. And yet it has all those mistakes. Is this because natural language is so much more difficult than vision? I don't think that's the answer. It's because, those 1.7 trillion parameters that we have here encode my place of birth in several languages. And there is really no need to put all this stuff into a language model if you can just access the knowledge from a declarative system or use it in different ways. If we would be able to push this knowledge out of those LLMs, we could get also much smaller models, which would be cheaper to run, and at the same time, they would be more accurate. So it's really a win-win if we go for that. So the suggestion here is that we extend LLMs also with structured knowledge bases, like, for example, Wikidata, and with a library of functions that they can call for function knowledge, like, for example, addition that we've seen before. And for this, we provide wiki functions from the Wikimedia Foundation. I will now introduce quickly Wikidata and wiki functions. So Wikidata is an open knowledge graph that anyone can contribute to, that everyone can edit, that has launched about 12 years ago, this month actually. And it provides a lot of structured linked data for all kinds of things. So Wikidata is also entirely multilingual, so you can access the page in many languages. And it is used extensively by Wikipedia, but also many other organizations like Google, Apple, Microsoft, the BBC, and so on. All of them are using Wikidata for various different purposes. There are about 37,000 research papers working with, on top of Wikidata or citing it. And also, so there are a lot of research teams that are using Wikidata and building on top of it. So what is Wikidata? How does it work? So in Wikidata, we have items which represent things in the world. So for example, we have an item for Stuttgart, we have an item for Split, for countries like Germany and Croatia, for the EU, we have items for people. And what we then have is that you have statements connecting those items as so-called properties. So for example, you would say Stuttgart's country is Germany, Split's country is Croatia. And you have this you can then add more different types of properties. For example, Croatia and Germany are members of the European Union. You can say the mayor of Stuttgart is Frank Knopper, the mayor of Split is Ivica Puljak. And the nice thing about Knowledge Graph is you can just keep growing. So you can add new items. Like, for example, we can just add an item for myself into the Knowledge Graph. We can add then a new type of property that can create new statements. For example, adding the place of birth. And we can then add them also to the existing items. You can say Knopper was born in Stuttgart, Puljak was born in Split, and Denny was also born in Stuttgart. So we have all this information and can put this into the knowledge. And the nice thing is we can all easily edit and understand what is being represented here in the graph. Unlike with an LLM, where the weights don't really tell you what they mean. Wikidata currently has almost 114 million such items. It started with everything that has a Wikipedia article, but has significantly grown since then. There are more than 1.6 billion statements connecting those items, adding more information about them. And all of it is available in almost 500 languages. How many websites do you know that have almost 500 languages available? It's pretty nice. The numbers that I'm really proud of, though, is that Wikidata has more than 23,000 monthly contributors, people actually working on Wikidata, editing knowledge. And in all together, more than 500,000 people have contributed to Wikidata over its lifetime in the last 12 years. I find this personally totally astonishing. When we started Wikidata, I would have never thought that there would be that many people interested in working on a structured knowledge base through the web. I'm just really, really happy about that. Wikidata so far saw more than 2 billion edits. That's more than English Wikipedia. Actually, it's by far the most edited wiki in the world. And now I can actually take Wikidata and ask, for example, for a list of the world's 10 largest city with a female mayor. That's exactly the question that we have asked before to ChatGPT. And I get a list back, and to the best of my knowledge, this list is quite correct. Is it? So since I've been looking at this for a while and have been looking with this question, I noticed Harbin here in this list on the third place, as you can see it, Harbin in China. And I haven't seen it on any of the others lists on the web that I've found. So I took actually a look into Harbin, and I saw that there was, that the mayor actually was an entity reconciliation problem. So the wrong person was reconciled with the mayor there. And it was actually, and it was connected with the wrong person, basically. The name looks the same in the Latin representation, but it was, it shouldn't have been, the mayor of Harbin is actually a man, not a woman. And the nice thing is, I could just click on it. I edited it, I fixed it, I changed it to the right person, I rerun the query, and it's corrected now. And that's something that you really can't do with an LLM. You can't just go in and say, oh yeah, you have here an error, let's fix this, and the next time someone asks you, please don't give the same wrong answer again. It's half a surprise if they give the same answer at all, but there's no way for you to actually contribute back to the LLM and fix this kind of errors. Whereas you can do that with structured knowledge because it is understandable what is going on here and how you can actually fix things. The LLM was still very, very useful because I used it actually often to create those SparkQL queries, which are used to query Wikidata. So SparkQL is a query language for knowledge graphs, and you can, and this is how I used to create, for example, the tables that you've just seen. And ChatGPT and other LLMs are really good at turning my natural language queries into formalisms like SparkQL. And this is just great because this helps with everyone getting more out of Wikidata. So really that also shows that it would be kind of easy to integrate a system like ChatGPT or other LLMs with a knowledge base like Wikidata, because it is able to actually create the queries that it would need to get information out of the system. So that's really helpful. And the last piece of the puzzle is Wikifunctions. So Wikifunctions is the first new Wikimedia project since 2012 when Wikidata was started. It was just started last year. It's also completely multilingual, but not only in terms of natural languages, but also programming languages. And what it provides is a library of functions. What does this mean to be a function? Well, a function is basically functions answer questions, and if something answers a question, it's knowledge. So functions are kind of a form of knowledge. It's not the same form of knowledge that you have in a knowledge graph. It's not declarative knowledge in the sense of the mayor of Stuttgart is Frank Knopper or something like this, but rather it's a kind of, well, it represents a function that can compute out of a question an answer, of a specific type of question, it can compute an answer. So we have the declarative knowledge in Wikidata. We have this kind of functional or computable knowledge provided through functions, through a library of functions. So simple examples of that, for example, is to we have a function that encodes a word as in the NATO phonetic alphabet. So you, for example, we take the ODI and it will say, oh, well, if you would do that in the NATO phonetic alphabet, it would be Oscar Delta India. And you can throw here any word inside and you get the answer back. Or we have a function that multiplies two natural numbers, something that those expensive LLMs are not so good at. And here you can easily throw in 20-digit numbers and even much bigger and get the right answer back. We have functions that count how many R's are there in strawberry or many other things. And again, we get reliably the correct answer here in those things. So Wikifunctions is this large library of functions. We currently have more than 1,600 functions available. It's still growing. There are already some functions which are quite nice and useful, but we have a limited set of data types currently, but we're working on increasing that and introducing that. We are available in more than 100 languages already, so meaning the names of the functions, the description of the functions, and so on. And you can just use the website in more than 100 languages. And we have contributors from more than 50 countries that have worked on functions in Wikifunctions. Page views are going up, still far away from Wikipedia or Wikidata, obviously, but it's showing that there's a healthy growth in the community. So Wikifunctions, the goal of Wikifunctions is to allow everyone to access functions and to answer questions, this kind of computable questions that have computable answers. Today, programmers have easy access to all kinds of those functions, but many other people do not. Non-programmers don't actually have this kind of access often easily available. With Wikifunctions, we want to expand the usage, but also the creation of functions. So you don't need to be actually a programmer to create functions. I haven't shown that part, but you can compose functions that we have together and get new functions out of the system. We aim to allow all people, even without them knowing English, to use functions, which is also something that most people, that people without knowing English don't have the access to create new functions, to implement functions. We think that there's a large pool of potential contributors who have all skills necessary to contribute functions, but don't speak English. We hope to unlock that potential. And we hope that Wikifunctions will lead to a comprehensive library of natural language generation functions for hundreds of natural languages. This is why we're building this. This is a major stepping stone for something we call abstract Wikipedia, and that we'll talk about in a moment, where the content of Wikipedia would actually propagate from one language to another, the original problem that we started to talk with. And all of these people, all of these functions won't just be available to people, but also for large language models. They can just use it as a library of functions and call those. And just to give one example of what I mean with all those languages. So Igbo is a language in Western Africa spoken by more than 30 million people. And they don't have a large library of functions. It's not like in English, where you can easily find a library for morphology, for syntax reading, and so on. So they have started to create functions for Igbo. For example, like this one, it takes a verb and gives you the imperative form. And it's amazing to see and get feedback from this community when they are building those functions, when they are working with those. And they can easily deploy these and make it available to everyone in their language just over the web. You don't have to install libraries, you don't have to run Python or whatever. You can just go to the website, run a function here, and you can do it for your language, in your language, and access it from there. This would be much more difficult if you wouldn't have Wikifunctions available. And to make it also clear, today LLMs are already starting to integrate, program synthesis and execution in the architecture. So for example, if you ask a question like this to ChatGPT today, what it actually does is not answering this question directly with the LLM, but what it really does is it writes some Python code, executes a Python code, gets an answer, and then uses this answer to actually answer your question. So this is similar to what I'm suggesting here, just with the difference that instead of coming up with the code on the fly, which is extremely expensive and complicated, use a library of functions that have been already tested, that have been agreed on by community, that have been worked on. It's basically a Wikipedia of functions you can trust and just use for all kinds of queries. And obviously multiplication is probably something where the program synthesis won't get it wrong, but you can easily imagine more complex queries and functions, like, for example, dealing with dates in different calendars and stuff like this, where the LLM might easily mess up even the writing of the function itself. So, of all these benefits, we're going to actually have a few advantages for building Abstract Wikipedia. So this is the architecture that we are aiming for, and with LLMs, we get a good new system that translates natural language to formalisms. We've seen it with SparkQL before, for example, and we know that this can help us actually to use knowledge representations that are much more powerful than the ones that we are used to. So we can have more complex formats, for example, to deal with brittleness better, to deal with fuzziness, to deal with vague questions, things that we have seen in the first webinar from Laura, for example, where it's not so clear cut how to represent a certain information or a certain knowledge, but rather it's a bit fuzzier. And natural languages are really good with that, and we can maybe build knowledge representation systems which are closer to natural language and allow for these more complex formalisms, because now we have LLMs that will actually translate that from one to the other. So we don't have to learn these complex systems ourselves, but we can just use natural language and then turn it into a formal system that the computer can reliably and with high fidelity use to answer questions and to represent knowledge. The main system where we are going to use this extended system is to have a frame-based representation of the content of Wikipedia, in order to have those frames then being translated into natural language, so that when you update the frame, when you have, for example, a new Nobel Prize winner, like today, Geoffrey Hinton winning the Nobel Prize, we can then easily generate this text immediately in all the languages of Wikipedia and have it updated throughout the 300 different languages after it was been added in a single language. And it doesn't matter in which language you added the core abstract content, it would always propagate to all those Wikipedias, and therefore bringing Wikipedia really a huge step closer to a world where everyone can share in the sum of all knowledge. Thank you for your attention.
Excellent. Thank you. So we have around 25 minutes for questions. I am going to share my screen now. So maybe if you stop sharing, I'm going to put a slide on that will say Q&A.
I'm happy to stop sharing and figure out how. Just a second. Wait. Did I stop sharing it or not?
No.
No. Here it is. Perfect.
Very good. So now my amazing slides, but I promise you there's a bit more. There we go. All right, very good. So the way I do this is I start typically with what I call my data-centric AI Proust questionnaire. So these are the questions that I ask everyone at the beginning of the conversation. So I'm going to do the same for you. So the first question should be very easy. What does data-centric AI mean to you, if anything?
What does data-centric AI mean for me? That we treat the data as a first-class citizen in our architecture of an AI system. That we don't just, use it for training the AI and then throw it away and lose the actual data and have just a mirage of the actual data available, but rather that we have the data properly represented in a way that it is directly editable and human understandable, and then can be used by the AI to answer questions, to create action and other things.
All right, so I'm going to deviate now from the question a tiny bit because I think it's maybe worth explaining for the benefit of everyone involved. Lots of people, I think 100 or at 159, we had over 170 people in the webinar with different backgrounds. So one source of such data are the knowledge graphs that you explain. Could you just explain in non-technical, ideally jargon-free way, what a knowledge graph is and how it's different from, say, a web page?
Yes, a knowledge graph is a structured representation. I hope this wasn't already too much jargon. As of simple,
like a spreadsheet. Structured. Think about a form of spreadsheet.
Yes, think of a big spreadsheet that has a lot of rows, a lot of columns, and where you can then say, like, there are all these peoples, they are born in those places, and that's basically already what it is. And so that the computer can easily, for example, look up, okay, someone's asking me about the place of birth of this person, or the date of birth, or where they are working right now, and so on. Like a big database. Where you have a lot of information, with the added benefit that knowledge graphs are usually a bit more flexible. They can easier add new entities to it, new kind of relations between topics and so on.
You can add columns and rows all the time.
Yes, and they are easily editable and most understandable. Often knowledge graphs is just represented as graphs, which is a big help with the intuition behind the whole thing, so that you can easily see, okay, this is graph, for example, here's the people in my classroom and who knows each other, or people over here are my colleagues, how are they working for each other, who goes with whom at lunch, and so on. All these things can be easily represented in a graph, or if you just imagine like drawing the people, drawing lines between them. And the computer can also access this kind of information easily. There are then standard query languages for creating questions, like, for example, which of the people that report to me go to lunch together usually, and so on. So, and this can
not that this would be something that I would ever ask. People who work for me, who can go for lunch with whomever they want.
Absolutely.
Just to make it absolutely clear. But maybe following up from that, say, in your opinion, since we've talked about ChatGPT a lot, so since November 2022, are knowledge graphs like Wikidata, have they become more or less important for the ecosystem?
I think they've become more important. I would have expected that if the promises that were made around knowledge about LLMs, they would have become less important, but they actually have become more important. They're used. We've seen that a lot of the answers coming from those systems, be it now Gemini, be it ChatGPT, and so on, are trained with knowledge graphs. Are coming from the information is coming from them, and extending the RAG architecture to graphs is an obvious thing that has been happening a lot. There are a lot of organizations that already have knowledge graphs internally, and if you don't, as an organization, you probably should. And using an LLM that then can have access to your knowledge graph can greatly improve the quality of your answer, can greatly improve the accuracy and the recency of your answers. Because if something changes in your organization, for example, the who reports to whom, or who is working at what desk, or suddenly everyone is in a different place, you can just update the knowledge graph and tell the LLM to use this new updated knowledge graph as a source of knowledge, instead of creating tons of documents that it reads and then hopefully gets the right answer.
All right, good. I've just realized how many questions we have. So now we're going to go really quick. So the first question really is, so there's a few questions that ask more information about how wiki functions work in Wikidata and Wikipedia and how that all fits together. I suggest we leave those and we send some links with the tutorial information that is already available. But I'll take the next one, saying one of the great aspects of Wikipedia is that it is collaborative. And human and community based. How do we protect the data in Wikidata from bots and AI generated edits and modifications? Do we protect it? Should we protect it?
Those are really good questions, and the community is trying to figure out answers for those questions. You wanted a short answer. So the current answer from the community for that is that bots are not agents with responsibility, but a human is always operating a bot. And if a change happens because a bot is doing it, the human operating the bot is responsible for that change. Which means that if a bot is adding nonsense and people are noticing, they will just block the user and say, you're out of the project, or stop doing this kind of things. So it's similar to what also a number of research publishers have taken as a rule. Basically, you can use generative models to create edits, to create text and so on. But in the end, you are 100% responsible for the content of what you are actually publishing. And you can't just go ahead, oh, sorry, this is what the computer, but this is what the model said. So the responsibility stops at the user actually operating those bots. So the community is not, in general, 100% opposed to those things, but they want to be a human who are actually checking the content. And if there's an edit that suddenly introduces, for example, that the birthplace of Denny Vrandečić is split, they would like to have a human check it and approve, and then the user will be responsible for that.
There's another related question to that, wondering about whether there is a danger that we end up with a Wikipedia or a Wikidata populated primarily with AI-generated information, whether fake or factually inaccurate, and whether you think, because you cannot speak on behalf of anyone, but whether you personally, having spent all this time in the community, see this as a threat or as a potential risk.
I see this as a possible threat and risk, but I hope that the community is resilient enough to stop that from happening. The bigger risk that I see is actually that our access to knowledge for the majority of people gets disintermediated from Wikipedia, so that we're just accessing now LLMs in some way, and we don't even know it comes from Wikipedia, and that we can go and edit it, and we don't have enough contributors to Wikipedia anymore. And that, I think, is a more immediate risk. And in that case, if the community stops caring for Wikipedia because there's not enough people to care about it in the left, then it will be easier for the bots to overwhelm Wikipedia, basically. And then everything is off. I don't know what will happen.
Yeah, thank you for that. And there's for those interested, there's also research that has looked at the impact of AI-generated text on a number of communities like Wikipedia, on Stack Overflow, on Reddit. We have done at King's in my team some research as well, looking specifically at engagement, traffic, and editorship in Wikipedia. And one of the conclusions, and there is evidence for this, is that if the site isn't just about the information that people contribute, but also has a resilient community that where the members feel as part of a community, then those effects are indeed, as Denny says, less strong. All right, so someone asks, very interesting question. Is there an app like ChatGPT, so I assume a chatbot, a question answering site, which uses natural language queries, so it's accessible, but that uses Wikidata and Wiki functions?
Not that I'm aware of. I don't think so that there currently is something like that. That would be an opportunity to build.
All right. Let's move to a slightly different topic. So I see there's a question about SQL and about training LLMs on premise. So the short answer for me is that yes, there are those solutions to do that for any type of private information. So you can deploy LLMs on premise, you can fine tune them, so that means retrain them or add on top of the training so that they work with your data and there's no, so you have those guardrails to your sensitive data. There's also a quick question maybe, about best approaches for converting natural language questions to Sparkle using LLMs. There's a lot of detail in the question specifically about the fact that RDF doesn't have an RDF dataset doesn't have a schema and how that actually works behind the scene, and whether perhaps Shackle, which is a technical format called the Shapes Constraint Language, or other tools could help. So any pointers to tools that do that?
Yes, so the University of Stanford has actually a recent paper on a system called Spinach, exactly like the vegetable, that has fine-tuned a model to create Sparkle queries over Wikidata. And they have explored a lot of different ways. So I would just suggest take this paper as the first entry to find results. And Spinach is great at producing the right question, the right Sparkle query for your question. Every time I have tried it so far, I was very impressed.
All right. So this is a very interesting question about the ecosystem, and thank you for saying I have addressed some of it. I think I'm going to ask some parts of it nevertheless. So it asks essentially whether you think OpenAI or other LLM tech providers have an incentive to introduce Wikidata, wiki functions, so these sort of knowledge representations, explicit knowledge representations into their functionality right now, especially considering the question goes on the downscaling of RAG and the trends towards larger parameters, multimodal models. So what's the incentive? What would convince them to use these sort of external sources of knowledge as part of the main release?
Accuracy and recency of the answers can be highly improved by using such a system, and cost in the end. There are estimates that, running something like Google with an LLM in the backend instead of the current architecture would cost about 10 to 100 times more than the system, and this is just not sustainable. And with OpenAI, we also don't know how sustainable the actual business model is right now. If each query costs as much as it seems to do, and how much money they can keep getting on this way. So I would say cost, accuracy, reducing cost considerably, having a higher accuracy, having a higher recency, and having higher coverage thanks to declarative knowledge is arguments that in the long term will lead. I think there's currently there's still the belief that a single architecture will get you very far, and that a lot of the AI researchers and practitioners in the field are not anymore as knowledgeable about, the classical methods that, for example, you and I have learned about symbolic knowledge, and that many of the younger researchers are actually really good at training the models, at fine-tuning, at parameter tuning and stuff like this, but are not even aware of all the different methods to answer questions differently. And it will just take, and because of the big success in this area, it will take a while to actually get the people with the right knowledge together and build such a system. But in the long run, I think there's a very clear economic and product quality argument for these kind of architectures.
Okay, so just related to that, because you have mentioned costs, and we had a question very early on in the presentation about carbon footprint. Could you comment on the environmental sustainability of some of these solutions?
If you run a question through 1.7 trillion parameters, you need a lot of compute for that. So this will cost a lot of power. Creating power currently creates a lot of carbon in many cases. So, and I mean, you've probably seen the news about switching on even nuclear power generators again, like the 3 miles power generator, in order to provide enough energy for compute centers that run those systems. So I think that reducing costs directly means reducing power consumption, directly means reducing the carbon footprint of those things. And
Okay. I
Yeah.
can add something to that. So there's some tools like I think it's called Carbon Code or Carbon Score that work with code. So imagine you're a machine learning engineer and you write computer code, and as you do that, you get some information about an estimate of the environmental footprint of what you're doing and some suggestions. They are not as widely used as they can be, and equally there's many ways in which these environmental parameters can be calculated and reported. There's also work looking at how specifically and when to communicate this sort of information to developers for individual decisions, but also work into advising organizations to take these decisions at an institutional level. But a very interesting space. I am going, just being mindful of the time, I'm going to take one question. We talked about how explicit knowledge representation in functional or declarative, so statements form, can add to large language models. There was a question earlier on in the talk about the role of reinforcement learning with human feedback, or AI auto-evaluation and training. So why wouldn't those work in the long time as an alternative to these sources of information that we have?
I've been trying it for 2 years, and we're getting better with those systems, but maybe it will. The thing with those methods is always that maybe they will work, maybe they won't. We actually can't even predict, right? If they will work or not. It's almost a kind of alchemy at this place, and we don't know how far the current system will take us, how much cost it will produce, how big do the models have to be in order to answer questions like those big number questions or about my birthday and stuff like this.
So it is a question of scale. It is a question of scale,
Yeah.
both on the model side, but also on the user side. Say, for me, the difference between the solutions is technical, like you were saying. So because of just how huge that probabilistic space is, we just aren't able to predict how much additional user feedback I need to improve according to a particular dimension, like accurate results or fast results or up-to-date results. We just don't know, and there's technical means to do that are limited. But then there is an ecosystem or an equity question to it. So at the moment, we're making this better or potentially possible for some types of questions only for a handful of companies. Whereas with the approaches that we have described, that Denny has described, anyone, the small business that want to get into the AI LLM ride, or anyone who wants to use these models internally for their purposes, they will not need those 100 million users to do the reinforcement learning with human feedback. And they will not need to invest $250,000 per data set to just remove like the most toxic parts of the technology. It's just there. You query it. It's either in your data already or it's in something like Wikidata. So I think that's important to state as well. Cool.
Yeah.
I'm going to be looking for an excellent final question. So someone is asking about contributing to Wikipedia, and they say they cannot contribute to Wikipedia because some bad actors have also used the same ISP, Internet Service Provider, and now all users from this ISP are blocked. And there's 120 million subscribers who use this ISP. So how does Wikipedia deal with that?
Badly. No, I'm very sorry for that inconvenience. This is not how it should be. It's a technical decision which the foundation and the community are negotiating constantly. I hope that can open. Usually, if you manage to create an account, you can circumvent this ISP block, and we are working on methods to improve that. And I hope that this will happen less. I've run into the same thing when trying to edit from mobile, and I really dislike it. And it often has ways to circumvent it. There are pages on Wikipedia discussing this, and you should be able to find it searching and try. So
maybe we can put the link as well in the summary
that.
when we send around the recording.
Yeah.
All right. Okay, good. So there's some silver lining. Well, thank you, Denny. This has been excellent. We didn't manage to go through all the questions. I am aware that we had 26 and we probably managed to get to 10 to 12. But hopefully we can provide some written responses as well to those interested. Just to wrap us up for today, oh my God, then all of a sudden I have this bright light in my eyes for some reason. So this is part of the data-centric AI program at the ODI, where we're doing things that aren't nearly as cool as what Denny presented, but we're very much aligned in our mission to promote the huge role of data, in particular data represented as formal knowledge, as Denny has shown, has in making AI systems just overall better, safer, easier to trust, more environmentally sustainable, more accurate. If you want to keep in touch with what we do, there's this QR code with a newsletter, and I've also taken the liberty, as always, to add some screenshots with some relevant work we have done recently. In particular, we have tried to use large language models to support people to do data work without having to become data scientists. So very similar to what Denny showed with that SparkQL code that I used to learn at the university, and basically it wasn't entirely a waste of time because that allows me to audit what an LLM has produced. But people these days have it easier. So we've done some work with Microsoft on trying to understand LLM capabilities around that. Also, one of our recent policy interventions around ensuring broad access to data for training AI models, and resources like Wikipedia and Wikidata play a huge role there. But there's also questions around, like you have asked today, about what the impact of large language models would be on those communities. And that's what my third screenshot at the bottom points to. So this is 21 of us met in a lovely place in February in Italy, and brought together a number of these volunteer platforms online and researchers supporting them to think about the role that these communities and the resources that produce have in the AI ecosystem. And the result is openly available on the Meta Wiki that's managed by the Wikimedia Foundation. And with that, final words. We'll meet again on the 19th of November with Nigel Shatwold, our co-founder and principal of the Jesus College at the University of Oxford, who is going to talk about how does data infrastructure look in the age of generative AI. Thank you very much for joining us. And we will reach out to you once the recording is ready and with answers and further pointers to the questions that you had. Thank you very much. Bye-bye.
Thank you. Thank you so much for having me.
Bye.